Good afternoon, grade 12s. I hope everything is still going well at your schools and your camps, and you're preparing yourselves for the final examination. Just a reminder, this is part 2 of the exam preparations that we are busy with. So it's important that for paper 1, you go and look into the previous video we did. It's part 1 of exam prep. So in part 2, the idea is we plan now to outline also the misconceptions or how best can you prepare for your final examination that will be coming soon. So here I have the demarcation for paper 2, and you can easily see that chemical change will now be around 92 marks. So it says when we plan our revisions, when we plan on what to focus on more, especially in paper 2, it means it should be for the chemical change. And thereafter, I have now matter and materials, of which we will do today, and a little bit of chemical change. So it's when you go and prepare, kindly refer to your exam guideline, because now it's clearly indicating which topics will have what percentage in the final exam. So this is key when we prepare and plan our lessons, because in each one of them it says to me I should be able to look for the achievables. I should be able to say this is the part where I am able now to get my maximum marks. So if I do not have this exam guideline, if I do not have this outline of the marks, automatically it says to me I will be studying, yes, but studying for things that are not going to assist me in terms of passing. So without wasting any time, let's start and say, when I look at my paper 2, the concepts that are assessed, or the topics thereof, yes, we have our multiple choice, which comprises of all the topics. That will be 20 marks. But the key idea here is to focus on more structured questions, because that is where we struggle most of the time. So when I look at the concept here, it says naming and structures. So it says to me I must be able to give all the definitions related to naming and structures. At the very same time, use now the IUPAC rule and steps to give the correct IUPAC name for different homologous series. So automatically it says whatever I do, I must be able now to give the correct functional group, give the correct IUPAC name, identify the homologous series thereof. Then the bullet that follows says draw structural formula for different functional groups and homologous series. So when you look at this, it will be plus minus 14 marks depending on what is asked, but somehow the maximum number of achievable, or the minimum achievable marks, will be around 7. So for me to get that, it means I need to be able to know my definitions, apply the rules of giving the IUPAC name, draw structures, as well as be able to identify different homologous series. So I usually do this summary for myself to say, if this is an organic molecule, of which we believe that the examiner will give to you, I should be able to say something about the functional group. So from the given organic molecule, am I able to identify the functional group? If yes, then it's a tick for me, because I will be able to say something along those lines. Can I be able to identify to which homologous series does the organic molecule belong to? Yes, if I can do that, then it says to me I am in the right direction, because the functional group informs the homologous series. And from the homologous series that is given, I can be able to identify the functional group. Can I say something about the IUPAC name? Yes, I can. If the IUPAC name is given, can I be able to identify the functional group? From the IUPAC name, can I be able also to give now the correct homologous series? Thereafter, it's now structural formulae. Structural formulae. So if I am given a structure, can I identify the homologous series? Can I identify the functional group? Am I able now to give the correct IUPAC name? The other one there, which is a pillar, it's the general formula. So from the given general formula, am I able to give now the structural formula? Can I draw from the general formula? Can I be able to say anything that has to do with the homologous series, functional group, as well as the IUPAC name? Therefore, the last one I can say it should be now isomers. So depending on what information is given, this is what I am expecting that should follow from the exam. So some form of organic molecule will be given, either in a form of an IUPAC name, structural formula, or any other information thereof. So in homologous series, I can further extend it to say I am going to have unsaturated hydrocarbons and saturated hydrocarbons. Saturated hydrocarbons. So now this will be my single bonds, and this will be my double bond and triple bonds. So this is key in terms of me being able to further extend the knowledge of dealing with organic molecules. Thereafter, with isomers, I can further extend it as well to say, but now I am going to have positional isomer, I am going to have chain isomer, and then I'm going to have now functional isomers. So this is me trying to say, if I am talking about a certain molecular formula, an organic molecule for that matter, sorry. If I am looking at this organic molecule, from each and every pillar that I have, am I able to relate or ask questions related to that? If I am given the IUPAC name, then it says to me the examiner can ask the functional group, homologous series, or even extend it further to saturated and unsaturated. If I am given now the structural formula, then the examiner can further extend it now to homologous series, functional group, IUPAC name, and now the isomers. So this is what we should have in mind to say when I am dealing and working with organic molecules. These are the possible pillars where the questions can come from. So if I am given a functional group, then I must be able to give the IUPAC name, give the isomers, the general formula, and the structural formula thereof. So I'm going to try and see if we can't apply this principle without necessarily answering the questions. Check if these structures of ours or the pillars are going to assist us. It says here, write down the letter that represents each of the following. So from above, we are given the letters A to E in the table, which represents 5 organic molecules. So I want us to look at this. I am given a structure here, and then condensed structures, and then I am given B there also. is it possible for me to say, but when I look at A, regardless of the questions thereof, when I look at A, can I address everything that is on these pillars of mine? So what is it that I am given at A? I am given the structural formula. So when I am given the structural formula, the idea is I want now to do what? To be able to say the homologous series can be asked, the functional group can be asked. They can even further ask me to give the IUPAC name. If it does have an isomer, then the chances are the isomers should follow. So I do not know the questions as yet, but by the mere fact of looking at A, automatically I can say, but now it says because the structure, the possible question thereof should be giving the correct IUPAC name. Thereafter, can I be able to say to which homologous series does it belong to by the fact of looking at it? I don't know the questions, but the idea is from these pillars, if I can be able to do that, to say, but now it has a halogen there, so it must be a haloalkane. So it means I have already addressed the issue of to which homologous series does it belong to. Hence, I'm saying this should be now the pillars of us trying to understand exactly how the examiners are going to assess. So if I was given an IUPAC name maybe somewhere here, it was going to be easy to say I have the IUPAC name, then the questions that follow should be everything along these pillars of mine. Then write down the letter that represents each of the following, and then the first one is a ketone. The first one is a ketone. So what does that say? It says in all these organic molecules that are given, what must I know? For me to know a ketone, it's important to know the functional group. It is also important to know the structural formula. Can you see now the link between all this that is given? So in this case, if I am given now the structural formula, it means from the functional group and the homologous series, I should be able to identify my ketone. And my ketone from this functional group, I can easily see that the correct answer there should be C. I further move on to 1.2. They say which one is now a hydrocarbon. Remember, with a hydrocarbon, it's compounds that consist only of carbon and hydrogen. So it can only be E or even B. I am looking for carbon and hydrogen only. So it's things that we need to know as well. The one that consists of an alkene is important. Now here is the challenge. For me to know an alkene, it's either I know it through the general formula, the homologous series, or even the homologous series is the one that is given, through the functional group, or even the IUPAC name. So when I look at all this, it means I must be trying now to look for either between B or E. But B, I cannot do anything with B because I don't know how many carbons I have and how many hydrogens I have. So the only option that I have here is E. Why? Because for me to be an alkene, it means I must consist of a double bond. So when I look at A, there is no double bond thereof. For me to look at C, it says C, we have already identified the functional group, so it becomes a ketone. Then we have an OH in this case, which will be an alcohol. So the only correct answer here should be E. And then if you are uncertain of your answer, usually the preferred method is for you now to draw these particular structures. At 2.21, write down the IUPAC name for compound A. I did say that because I am given a structural formulae, possible questions to follow should be give the homologous series to which it belongs, give the functional group, give the IUPAC name. So the examiner now is asking us to give the IUPAC name. Hence, it is saying there in our achievables to say, use the IUPAC rules and steps to give the correct IUPAC name for the different homologous series. So it's key for each and every one of us to be able to give the correct IUPAC name. And from the IUPAC name, you should be able now to draw the correct structures. So it's interlinked between the two. So if you are given the structure, expect the IUPAC name. If you are given the IUPAC name, expect now to draw the structure and any other things that relates to that. So the correct answer there is 2-methyl, 2-bromo, 4-methyl, 3,3 dimethyl hexane. So kindly go back, look into it, and ensure that now your substituents are arranged in alphabetical order, because one of the misconceptions or the common errors that you are doing is you don't arrange them in an alphabetical order, and then thereafter you do not use the hyphens thereof. So if you can check the marking criteria, it says for the correct stem, that is now the parent name hexane, there is a mark. All substituents bromo, ethyl, and dimethyl have been identified correctly. And then the substituents correctly numbered in alphabetical order, hyphens and commas correctly used. Can you see that? So the other mark is for ensuring that you have the correct number or the correct position of bromo, for ethyl, and then 3,3 dimethyl, and now the use of a comma thereof. So if it happens that you omit this comma, it means now the other mark or the mark that will give you now 3 out of 3 will not be given to you. So this is a marking criteria that we generally use in most cases when we work with giving the correct IUPAC name. So when you deal with correct IUPAC names, kindly ensure that you have the number for each substituent, and remember it should be the lowest possible number. Thereafter, arrange them in an alphabetical order and then give the correct stem or the correct parent name. After that, just ensure that the numbers are correct, the hyphens are correct. If there are commas, we use comma between the numbers. If the commas are there, they are also used correctly. So that is a way of us saying the marks are there only if you apply now the correct IUPAC names. So this has been exercised quite a lot in our classes, in the previous exams, so we cannot be continuing to do the very same mistakes that we did throughout the year. So let's go back, look into it, and just ensure that you follow this type of analogy or this type of pillars strategy of when you study. So when I look at single bonds, let me say I'm putting single bonds here, can I give the names of single bonds in terms of the IUPAC? Can I write the general formula? Does it have isomers? Can I give the structural formula? Is it saturated or unsaturated? Do I know how to draw the functional group on its own? So if all these pillars are closed, even if I am talking of an alcohol, if I have an alcohol here, can I name alcohols? Can I write isomers of alcohols if they do have one? Can I be able now to give the general formula of alcohols? Can I be able to give the structural formula? Is it saturated or unsaturated? But in our case, we are only looking at hydrocarbons. Therefore, further on, do I know the homologous series to which it belongs? Then the functional group thereafter. So with this, it becomes easy, it becomes clear to say, these are things that I need to look for. the examiner will ask me things along those lines. Then we further go on. Draw the structural formula of compound D. So compound D, we are given a condensed structure. So from the condensed structure also, it means we must be able to draw. So when we draw, you will get something along these lines, and then one for the functional group, and then for you to have the 6 carbons and the correct position of the functional group. This was fairly easy to do. I didn't see anyone struggling during the time of moderation. We further move on and say the IUPAC name of write down the IUPAC name of the straight chain functional isomer of compound C. Straight chain functional isomer. Let's go back to this. We are looking at C. So C is a ketone. We did identify that. So what are they asking? The isomer. So is it going to be positional chain or functional? It is going to be functional isomer. Because remember we said a ketone will change to an aldehyde. An aldehyde will also change to a ketone. These are my functional isomers. And then the other one is if I have an ester, the ester now will change into a carboxylic acid, and the carboxylic acid will change now into an ester. So because I am given a ketone, automatically I am expecting to have now an aldehyde. So the name thereof of that aldehyde should be pentanal, and the instruction is clear. The IUPAC name of the straight chain functional group, functional isomer. So we are told that it is a functional isomer with a straight chain. So it brings me back to this. If I am given a ketone, do I have anything to say about the isomers thereof? So this is the pillars that you can use when working with organic chemistry, when working with naming and structures. So once when you study and the plan is you are able to say each and something about each and every one of them, automatically everything will sit into place and will somehow be correct. So that is basically it. The below part is part of the reactions, so I'm not going to further extend it because I want to emphasize more when we get to the part of reactions. So it's more of your stoichiometry calculation, so we'll address that when we go to question 4. So in question 3, it's physical and chemical properties. We will also try to design some form of a plan or a mind map, or these pillars that guide us in terms of how to address each and every particular question. So I'm giving you this crash course quickly because the idea is I believe that it's things that you already know, but not necessarily know the link between each and every one of them. And why will, in most cases, say, but now the questions were different. The questions were different. It looked difficult somehow. The reason is when we studied, we did not necessarily address all the gaps thereof. So hence I'm saying if you are looking at an organic molecule, kindly ensure that you are able to say anything about the general formula, anything about the isomers, anything about the IUPAC name, anything that has to do with the functional group and the homologous series. Further extended it to saturated and unsaturated. So when you study, if that is your way of looking at a molecule, automatically you have answered majority of questions or possible questions that will be asked in an exam. So let's move on to physical and chemical properties. We also have our possible marks or achievable marks. So for physical and chemical properties, its definitions. Identify different types of intermolecular forces and their strength, and then you should be able to interpret data and graphs that is given. So it will always be a question of comparison in most cases. So if it's a question of comparison, it says somehow I must have factors that are influencing my comparison. So I'm going to start and say, let's generate now pillars also for physical and chemical properties. And chemical properties. So we are trying now to create a platform where we are able to say, if this can be addressed, then we have closed the gaps in working with chemical and physical properties. So I'll say I have my factors here, or the properties which are physical and chemical properties. But the most important ones is boiling point, melting point, and now vapor pressure. This is what we look for, or the properties that we are going to discuss in detail. But definitely I have now factors that influences these particular properties. The very first factor is chain length. The second one is number of branches. The last one will be now the functional group. Will be now the functional group. But in an exam, how do I identify that the examiner now is asking me about chain length? How do I know that now the examiner is asking me about number of branches? How do I know that the examiner is asking me for the functional group? The functional group is easy because now molecules must have different functional groups. So once I am comparing different functional groups, it becomes easy that I am looking at the functional group. That one is quite easy to pick up. Now, for the chain length, it says those molecules must belong to the same homologous series. They must belong now to the same homologous series. And for the number of branches as well, they must belong to the same homologous series. But it is not helping because I can see that they belong to the same homologous series in chain length, and they belong to the same homologous series in the number of branches. So to eliminate the misconception between the two, or for me to be able to identify it fully, it means I must add something extra for me to be able to say, yes, they both have the same, belong to the same homologous series, but with this, I can be certain to say it is the number of branches, it's the chain length. So for me to compare a number of branches, it means they must be isomers of each other. So isomers, same molecular formula, just a different structure. So for the same molecular formula, we can add to say now they must have the same molecular mass. Same molecular mass. So once they have the same molecular mass, it means they are isomers of each other. So I can further say here, for me to compare chain length, it means they must be different molecular mass. So I have added this bullet for me to be able to compare